Hi everybody, this is 2.1 continued transformations of functions. In this video we're going to talk about stretching and compressing our functions. So when we stretch and compress, what we're looking for is a number inside or right in front of the function. Okay, so when you take the absolute value of that and it is greater than 1, it is going to be vertically stretched, which means we are going to take every y value and multiply it by a. So here, in example A, I have my parent function, that is the dotted line. Okay, so that is my parent function of y equals x squared. My transformed function has a 2 in front of it, which means I am stretching my graph vertically. So I started at 0, 0, and if I multiplied that y value by 2, I would also get 0. Then my next parent function started at 1, 1, but if I multiplied that point, that y value by 2, I'm going to get 1, 2, which I have a point. Then I had 2, 4 on my parent function. If I multiplied y by 2, which would be 4, 4 times 2 is 8. On my transformed function, I have 2, 8. So again, all we did was take the y values multiplied by 2, and it stretches and makes it skinny. The next one says that if it falls between 0 and 1, the graph is going to be vertically compressed. And again, we're multiplying every y value by a, and that's how we get this. So if we look at B, notice that this 1/2 is between 0 and 1. So if I take my y values of my parent function and I multiply them by 1/2, it's going to compress my graph. So if I take 0, 0 and I multiply the y value by 1/2, I still have 0, 0. If I take this point at 1, 1 and multiply the y value of 1 by 1/2, I get 1, 1/2, which is where that solid line is. If I take my y value at 2, 4 and multiply it by 1/2, well, 4 times 1/2 is 2. So notice I have a point at 2, 2. So it's going to keep getting wider and wider. Now, the bigger the number A is, the more steep or more narrow it looks. The smaller A is, the more wide it gets. And again, you can graph these on the calculator to see them. That way you get some calculator practice. Okay, the next one we're going to talk about horizontal stretching and compressing. So this is now when it's inside directly with the x. So if there's parentheses, it's inside the parentheses. If there is a radical, an absolute value, it's directly inside. So when b is greater than 1, it's going to be horizontally compressed, meaning we will take every x value and divide it by b. So if I look at this first one right here, I see that it is greater than 1 on the inside. So that is going to be a horizontal compression. So we would take each x value and divide it by b, which is 2. So if you notice, my parent function is at 1, 1. And you don't have to write this down. And then I'm just going to pick another one. Let's do 4, 4. So if I multiplied those x values by 1/2, or sorry, yeah, 1/2 because it's 1 over b, that would give me 1/2, 1, which is where that new function is. If I multiplied this x value by 1/2, that would give me 2, 4. And if you notice, I have a point at 2, 4. So that's all we did to get those values. The parent function of this is just the absolute value of x. Now, when b falls between 0 and 1, when it falls between 0 and 1, the graph is going to be horizontally stretched. So, again, every x value is going to be divided by b. In this case, my b value is 1/2, which means it's horizontally stretched. My parent function is still the same, the absolute value of x. So notice how when I'm stretching it horizontally, it's getting wider and wider. Whereas when I was compressing it horizontally, it was getting more narrow. So you have to think about pulling the graph along the x-axis to stretch it or pushing it, the x-axis, together to compress it horizontally. When we're thinking about vertical stretching and compressing, we're stretching the y-axis out and then we're compressing the y-axis in. So that's all the transformations. We have some examples, so I want you to pause and try to do example 1 and 2 on your own, and then come back and check your answers. So on example 1, we want to identify the parent function and state all the transformations. So what I like to do is I like to highlight each transformation that I see, and then each transformation is going to have its job. It tells us how to move. Now, if I were to take off everything that I highlighted, what would we be left over with? Well, that would be y equals x squared, which is the parent function. So let's take it transformation by transformation. There's a negative out in the very front. It's not touching the x, it's out in the very front, which means that it's reflecting over the x-axis. Then that 1/4 out in front is telling us that we are having a vertical compression of 1/4. That +3 on the inside, we really want to say that it's going to the right 3, but we know that it's trying to trick us and it's going to the left 3. And last but not least, that -1 tells us that it's going down 1. Now, on example 2, it says write an equation f of x of a square root function that has been vertically shifted up 7 units and reflected about the y-axis and vertically stretched by a factor of 3. Well, first off, it told us that we're using a square root function. So I'm going to go ahead and write out my square root function. And if I need to add stuff, I can. So first off, we want it to be vertically shifted up 7 units. So to be shifted up 7 units, it needs a +7 on the outside. Then we're wanting it to be reflected about the y-axis, which means that it needs to go inside the radical. And then lastly, we want it to be vertically stretched by a factor of 3. So that means it's going to go out in front. And this right here is my transformed function. So at the end, you have your summary. So it gives you the function notation. It gives you the transformations that happen, and then an example with different types of functions of each transformation. So these transformations are going to work for every single function we talk about. So please make sure you keep referring to this page and you don't lose it. And if you have any questions, write them down and make sure you ask me in class.